All right, so let's check our answer to this initial value problem. The auxiliary equation you should write is 4m squared plus 4m plus 17 equals 0. I'm going to go ahead and just plug this into the quadratic formula and not try to figure out what the factors are and just see what happens. So I get -4, negative b plus or minus, square root of b squared, so 16 minus 4ac. Okay, I'm glad I did that because that's going to be 16, so I'm going to have a negative here. All over 2a. All right, inside my square root, I'm going to have, let's try to do this a little bit tricky. 16 minus 16 times 17 all over 8. Well, if I factor out a 16, I'm left with 1 minus 17 on the inside. And so I end up getting 16 times -16, or -16 squared on the inside of that square root. So this is going to be -4 plus or minus the square root of -16 squared all over 8. All right, in this case, we then have plus or minus, well, square root and squared cancel, makes this 16i. And so I'm going to get that m1 is going to be -1/2 plus 2i, and m2 is going to be -1/2 minus 2i. Or if I combine this as a complex set of numbers, alpha is -1/2 and beta is 2. I don't worry about the plus or minus, that's part of this piece right here. All right, that tells me that my solution curve is going to be C1 e to the -1/2 x cosine 2x plus C2 e to the -1/2 x sine 2x. I then have two pieces of information that were given to me at the beginning of the problem. The first is that y of 0 is -1. So -1 is equal to C1 e to the 0 cosine of 0 plus C2 e to the 0 sine of 0. Sine of 0 is 0, cosine of 0 is 1, and e to the 0 is also 1. So I'm left with -1 equals C1. I'm then going to plug that back in. Because I've solved for one of my constants. My next term that I could plug in is y prime of 0 equals 2. Well, now I need to find y prime. And I'm going to have to do a product rule twice. So notice there's a product here and a product here. Derivative of the first, e to any power, I bring that power down, +1/2. Well, I take the derivative of the power. I shouldn't say bring the power down, that's more power rule, but I take the derivative of that, so I get +1/2 here. Leave the second, plus the first. And then the derivative of the second would be negative sign. So I'm going to make this a positive 2 coming from in here, sine of 2x. I'm going to do that same thing here. I take the negative 1/2 because it's the derivative of this piece. Leave it. And then the derivative of here is going to be 2, I'll sneak that in there, cosine of 2x. All right, when I go to plug in my initial condition, everything that has a sign is going to end up being 0. So I'm really only going to worry about cosine, and the cosine of that is going to end up being 1. E to the 0 is also 1. So all of that is going to end up just giving me positive 1/2, 0, 0, plus 2, C2, 1, and 1. So I have 2 equals 1/2 plus 2, C2. I could solve this a couple different ways. I could subtract and then divide by 2. I personally like multiplying through everything by 2 and getting rid of this here. So 4 is 1 plus 4 C2. Subtract, divide, and I get that C2 has to be 3/4. And that's what I would plug in here for my final solution.